This is the demonstration video from Trim 3 demonstrating the indoor positioning function. The video took place on the 6th floor, AC3, City University of Hong Kong. We simulate an open area in a bank branch. Currently, I'm standing at the entrance of the floor, which will be revealed as the red dot on the interface. So I'm started to walk around the area. You will soon see the movement of the red dot will be changed accordingly. Currently, I'm walking towards the customer service. We assumed the signature of the IS department to be the customer service counter. You may realize there is a delay of the red dot, which is actually the technology limitation from the estimate beacons. And now I'm heading to the ATM. We assume the TV stands to be the ATM areas. You may see that the red dot is actually quite accurate. Roughly more than 70% of the red dot position is actually the real-time location of the users. And now I'm walking out of the branch, and you may see the red dot is actually approaching to the entrance or exit of the map. This is the demonstration video from Team 3 demonstrating the indoor navigation function. The video took place in one of our groupmates' home. The reason behind is to examine the indoor navigation function under a very small area with all kinds of obstacles within it. Now, I click on the customer counter button and the application immediately shows a blue trace navigating me towards my destination, which is the customer counter. And now I'm approaching towards my destination. And you can see the red dot is actually my real-time location within my area. We assume the TV to be the location of customer counter, and now I arrive at my destination and clicked on the clear button to clear the trace. Now I clicked on the exit button to simulate the users exiting the bank branch. Actually, our navigation function is performed by algorithm, which means that we did not hardcode anything besides the coordinate of the destinations, which means users can actually navigate towards their destination from any starting point. And this is the flexibility from our algorithm. And this is the end of our demonstration video.
Our team has developed a data analytics platform to show what kind of insights can be generated by the data collected by our app. First of all, we can find out the total number of users of our app, as well as the counts for navigating to different services. For example, there are 14 counts for navigating to floor 1 ATM. We also provide a function for operation managers to check the information of a specific customer by entering email. For example, we can check the user ID as well as the navigation counts data. It is also possible to add more demographic data in the future so as to generate more insights. We also provide a function for managers to check the number of customers in a specific period. For example, if I enter the date and time here, and then click check, then a pop-up message will show us how many customers are there in the branch. And at the same time, the manager can also choose to check for the real-time data by clicking this button. And lastly, we have a function for generating heat map. The heat map is generated by the positioning data from beacons. And same as the previous function, the manager can choose to enter a specific time and period, or he can also check for the real-time data. For example, if I enter the dates here and then click generate, Then a heat map will be generated here. And by default, the radius of the data spots are 60 pixels. If the managers want to change it to a smaller size or a larger size, he can do so by typing in this text box. Let's say setting the radius to 30 pixels, and then click Generate. Then a new heat map with a new radius of 30 pixels will be generated. So, these are the functionality we have developed for our platform so far. The reason why we developed this platform is to show the possibility of applying analytics based on the data we have collected from our app. Thank you for listening to our video.